better one there? Boy.
Good.
All right. Okay, so today, here's what we're going to be talking about. Number one, we got to go through some of your properties. So, as I promised, I was going to hand you your property sheet. This is the one that we discussed in the last couple days in here. Hi, you guys owe me 10 minutes. Yay. Bye. One, two, three, four. Okay, now, on your property sheet, does everyone have one in front of them? Okay, it's got every property. Now, you are not allowed to add anything to this, but you can highlight things. So you can, like, color it wherever you need to do. Some people, like, when they look at it, they'll highlight, like, the actual names. So, in fact, let me put it up on the marker board so you can kind of see what I'm talking about here. And then what we're going to do is we're going to discuss the last property. Because we have one more property that I want to discuss today, and I thought that was a perfect topic because we're going to really outscale the lane. So, it'll be perfect for what we need it. Alright, so first and foremost, so on this, what most people do is they'll highlight like these. These are the main ones we use for when you have an equation. So we have, that 3x plus 1 equals 5, and you need to solve. These are the main properties that we use, right? We use a lot of the addition property, equality, multiplication, subtraction, division. But what we learned yesterday is those extra few properties, the ones at the very bottom. Because on Monday we introduced the field properties. Well, yesterday we almost wrapped them up. So in fact, let me scroll down to those. So we're at field properties now. So these are the three we introduced Monday, right? We had closure. The closure property was substitution, so when you do simple math in the middle of a problem. We talked about commutative, which is when you move items around. That'll be kind of a one that we'll talk about today once we get there, because we haven't really seen commutative yet. We haven't really needed it for problems, but we'll eventually see that. Associative is when you move parentheses again. There's limiting situations where we use associative, and that's going to be after distribution. So that's actually one of the topics we'll talk about today. And so those are the ones from Monday, but we really haven't discussed these two very much. And the other ones that we talked about yesterday, we introduced the identities. Now, there is two identities, and these are the ones that for sure you definitely need to highlight somehow, some reason, if you have a marker, if you have a color, because some people, for some reason, people don't remember that these are the names I want you to know, these two. They're italicized, like those are the names of the properties you need. Don't call it just identity, call it additive identity when you add 0 to something, or multiplicative identity when you multiply by 1 onto something. So that's something you need to realize. Okay, those are the ones we introduced yesterday. And, I'll do one example, kind of like the type of problem that we talked about yesterday, where you'd see these, like how you do that type of problem. Then the last two that we discussed the inverses. Now there's two inverses, and it got cut off by the page break. So that's where if you look at the bottom of your property sheet, it flips over to the next page. So the first inverse property we had was the property of opposites. That's at the very bottom of your page. That's when you add numbers and it makes 0. You usually do that for an equation when you're trying to cancel out stuff. And then the other one, so that's called property of opposites. So that's one that you definitely need to highlight right here. Highlight that on that page. And then the other one is called the reciprocal property. That's when you divide numbers and it makes the number 1. You also have to do that for an equation. So those, for a fact, you definitely need to make sure that you're highlighting, that you know, like, those are the names of the properties that you're going to be using. Because if you see the highlighter, you know, like, those are the property names you can use. Now again, this property sheet, this one right here, you can use this on the test. You can't add anything to it, but you can use this so that you know the names of your properties. So you're not, like, scrambling to figure out what they are. Because that's probably the worst part, is trying to remember, like, different names. You need to get really familiar with the sheet, so it's not one of those things where on test day, you're just staring at it blankly. You need to know, like, the names of the properties and use it. Because there's a ton of points for doing proofs. I mean, every line is a point. So when you have an 8-line proof, that's 8 points. You don't want to just like, oh, I don't know how to do it. It's not acceptable. You got to know it. That's what the whole point of this class is. Now today, we are going to introduce a new one, distribution, distributive property. We're going to spend some time on that, and I'll tell you kind of where it came from originally and all that good stuff. But let's do a quick recap of like a problem that gave us some of the things we learned yesterday. Okay, so in fact, I'm going to put it over here so we can discuss it. Okay, so this is going to be just a quick recap of the problem we had yesterday. So let's go with 4x plus 2 equals 10. Now let's do something like that. Just an easy problem where we can kind of solve it. Okay, we're going to go through every step on this problem, and it's going to cover basically the majority of the properties that we discussed yesterday. So the properties, obviously from yesterday's substitution, commutative, associative, the identities, there's 2 identities, and then the inverse properties, reciprocal and property of opposites. Okay, but what do you remember from yesterday? How many steps does it take to get rid of a single number? 4 steps. It's always the same 4. That's the weird thing about this. The 4 steps we're going to take. The first one will be some property of equality. In fact, I'm going to put the properties over here. It'll be some property of equality. So we'll either add or subtract or multiply or divide by something first. Then, right after you do a property of equality, we have to do some type of substitution. Usually the substitution is on the right side. There's some type of math you need to accomplish. Then on the left side, it'll be some type of inverse property. And I'm just going to put inverse. Okay, it'll be one of the two. Okay, whatever it is. Okay, the inverses are reciprocals or property of opposites. One of those two. And then what we always finish with is we always finish with an identity. One of the two. So one of the 2 identities. So we have additive identity or multiplicative. Okay, that's the idea. Now, when you do this problem, if you're not sure of the property names, the way to save at least a few points is just do the math correctly. Like, just solve it out and try to get down to the answer. Because at least you're getting some points. Because if you don't know how to solve this problem, there's no help for you. You're in the wrong class. Okay, you should at least get down to that final answer where the answer is 2. Right? X is 2. But you got to at least show some work. Now, the property names, like, you should always go in batches of 4s. These 4 in order, and the next 4 in order, and that. And how I know, like, the order to go in and why it's that is because this is the order how you solve equations. Right? That's just the little acronym we use. It's called SADMAP. It's PEMDAS backwards. It's the order of operation backwards. So you always want to add and subtract first on this problem. Then if there's no adding and subtracting left, then you multiply and divide. And if there's none of that, then you look for exponents or parentheses. So on this problem, what's the first thing that I need to do? Subtract 2. That's actually your first property. So we're going to subtract 2 from both sides. And just the simple fact of writing subtracting 2, that's the subtraction property of equality. Okay, just the simple fact of putting minus 2. Okay, that's what you have to do in your homework. So that shouldn't be something new. You should be comfortable with that. But now going further, now this is where the new stuff came in from yesterday. So yesterday, what's 10 minus 2? 8. That's substituting. You're doing simple arithmetic on the right side and getting a random digit that wasn't on the board previously. On the other side of the equal sign, we ignore that. I'm going to ignore that. The plus 2 minus 2, because that's a different property name. That's actually the one coming up later. It's actually the inverse property. Okay, but does everyone understand the substitution step, the 10 minus 2? Okay? Is your name on that? Is your name on that? Okay, good. All right, on the left side now, the 2 minus 2, what does that make? 0, right? So 2 minus 2 is 0. That's one of the inverse properties. Anytime you add or subtract numbers, it makes 0, or if you divide numbers, it makes 1. That's inverse property. Now, the property we're doing here is the property of opposites. So you can, I don't know, can you see it on the board up there? No, it's right above the reciprocals. I don't have that on the board yet. But property of opposites, when you add numbers and it makes 0, it's making a special number. It looks like substituting. It looks like you're just doing simple arithmetic, but 0 is a special number. So you got to remember that's a special property name. It's not substitution. Okay, then the last step, what's 4x plus 0? 4x. And anytime you add 0, that's an identity, or if you multiply by the number 1, that's an identity. This one happens to be the additive identity. Because common sense, why it's called additive, you just added 0. That's the concept. Okay. All right, I'll stop there just for a few seconds. Took 4 lines, exactly 4, and we got rid of the number 2 on that problem. So now, how many lines will it take to get rid of this 4 now?
4.
4 lines. It's the same 4 in that order, exactly, right? Maybe the name of the inverse will be different and the identity will be different, but it's basically these 4 in that particular order. So, kind of blitzing through this, keeping it color-coded. The first step I'm going to do is divide by 4s to both sides. So that's division property of equality. That's property of equality first. Equality. Notice I don't write just division. You have to write property of equality because we're going to learn multiple definitions or multiple division properties, multiple multiplication properties, multiple addition and subtraction properties. So you got to make sure you're very clear on which one you're doing. Doing the property of equality because I'm doing it on the side. Okay, on the right side, we're going to substitute 8 divided by 4. 2, and on the other side I'm going to leave this alone, 4 divided by 4. So that's substitution. This is simple arithmetic, random stuff. On the left side, 4 divided by 4, that's very, very specific. That makes the number 1. And that, the simple fact of dividing 4 by 4 and making 1, that is an inverse. Now the inverse is actually, it's on the board right now. The top one over there, it's called the reciprocal property. Your reciprocals. When you divide numbers, it makes number 1. There's 1 special in that. So is 0. So making those two numbers is not substituted. Then your last step, 1 times x. 1 times x. X. And that's an identity. In fact, what we're doing there is the multiplicative identity. So we multiply by 1. Multiplicative or multiplication property, I don't care what I call it. Multiplicative identity. That's what we talked about yesterday. So this is an exact mirror image of that one problem I did yesterday where I was tossing the little huge ball around and trying to get people. Okay, that different. Okay, questions, comments on this problem? Okay, that's a great example to have. This is what I expect you to be able to do from now on, especially on the next homework. You have to give me, these exact properties to do those types of problems. You can't just write, oh, I'm subtracting both sides and writing down the answer. That's what we did in the previous one, page 139. That was the one that was due yesterday. Okay, questions, comments? Okay, let's talk about our new property today. This is new. We haven't talked about this yet. Distribution. Now, most people know what distribution is. You can probably think of it like how you'd use it in algebra class. But the goal today is to really show you where it comes from, why do we have it, where you find it in your property sheet, that type of thing. Right? All right, so distribution, just so you know. This is a distribution property. It's right here, basically. It's anytime you have some parenthesis like that, and you're going to multiply a number through. Okay, so you're going to multiply the number through. And most people know, like, when you distribute, you're taking 3 times the 2, and you're getting the 6x, and eventually taking 3 times the 4, and you're getting 12, right? Now, here's the weird thing. This is the answer for the problem. Distribution is the simple fact that you handed the 3 out, which is weird. That's what a lot of people always mistake. That they always think that you go right to the answer, when there's actually a bunch of properties where what you have to do is you have to actually hand the 3 to both items. You don't actually multiply it on right away. So what you're looking at here, that's distribution. Right there. That's the distribution step. Did I multiply them? No. I just handed the 3 out. Now, what I always call distribution, I call it turtle method. It's just Miss Penning always talked about it. It looks like a turtle shell. I don't know why. That's the way she taught it in class. So I just thought it was interesting. But notice, I'm just handing the 3 out. Now, what about this problem? So this is one, because most people know that problem. This is one you used out distribution in Algebra 1 class. But what about this problem? What about that problem? Do I distribute over that? Okay, you gotta know why. Why would I not distribute on this problem? Anyone have an idea? What do you think? What's your initial thoughts on that problem? Why wouldn't I distribute on that problem that I did on this one? What's the difference? Okay, it's got 2 variables, all right, so that's a big difference between them. I agree with that. There's 2 variables. But what else? What's the main difference between this parenthesis and that parenthesis? Exactly. It's one single item in that parenthesis. It's one item. Sure, it has a couple variables, don't get me wrong. It's got a name beyond it. But it's literally a single item. This item over here, this is actually what we call a binomial. In fact, let me get this little turtle out of the way here. This is a binomial. What makes it a binomial? It's 2 things being added or subtracted together. Okay? And can I actually add these 2 things together? No. So it's separate. There's 2, bi meaning 2. Right? Over here, this is one single item. It's not being added or subtracted to anything. So this is what we call a monomial, a single item. Mono meaning 1. Right? So when you have a monomial, you're just taking the 3 times the 4. You're not actually distributing the 3 to everything. So that's a big difference. That's why you don't distribute like this one where you hand the 3 out to everything. The 3 and the 4 are just being multiplied and the letters just get tacked on the back. So that's not a distribution problem. What about this problem? Would I distribute? Yes or no? No? Anyone say otherwise? Okay, why not? What's the difference? Why would I not distribute on that red problem here? How's it different than the first one? Yeah, it's multiplying. It's not adding or subtracting. You only distribute, if you look up here, you only distribute over addition symbols or subtraction symbols. This problem, this item here is a single item. You can actually multiply anything in the world together. Multiply anything. different letters, whatever, you can multiply. This actually turns out to be, eventually, it will turn out to be a 10x. We actually multiply that, so I can actually simplify that down. And then you wouldn't need to distribute the 4 over it. It's just 4 times 10. There's no distribution needed, because it's a single item. It's this problem, again, it's a monomial, it's a single item. If you can't add or subtract them together, then you have 2 separate items. Then you have to distribute over it. You can distribute. Do distribution over like 20 items, as long as there are plus and minus items all in between them. When it's multiplying or dividing, you can't do it. So that's the big difference. All right. Does everyone understand like distribution versus not distribution? Okay. We haven't even talked about the actual process here. There's quite a bit you actually have to do when you distribute things. But let's discuss. I want to discuss like why do we ever come up with this math? This seems silly. Like why would we ever need this, or what was the purpose of it originally? Distribution originally was created for this type of problem, which is weird because that problem is not like, it doesn't have a plus or minus sign. Agreed, it's just 2 numbers being multiplied. But what most people don't realize is that the actual result of this problem is made by using distribution. Like most people would need a calculator to take 7 times 98, right? But what you don't realize is that there's a quick answer on this problem to get to 684. Or 686, I should say, 686. Okay, there's a quick way to get to that result, like without using a calculator. Because how this works is that the number 98 is the same as writing this. Would you agree that 98 is the same as 100 minus 2? Agree? That's 98 in the parentheses there. Well, this problem is actually easier to multiply in my head than that one. That's how I came up with 686. Because what I actually do is I distribute the 7 over this parenthesis, because it's a minus sign, so I'm allowed to do that. So, what's 7 times 100? 100, right? And 7 times 2? 14. Well, I didn't take 7 minus 14 in my head. 700 minus 14 is easy. It's 686. Right? So I'm just taking 10 off, so that's 690, and then take another 4 off. So 686. That's how I came up with that number in my head. Okay? That's easier than trying to like straight up, because I know like when some people multiply, raise your hands. How many people, like when you multiply like numbers like this, you still do like lattice method or scaffolding, whatever you call it? Does anyone do that? You never seen lattice method? Oh, this is
lattice. I love lattice.
Some people do it. I find this weird. This is just something that's kind of come up in the last couple of years. This is just the way that some teachers teach it. How lattice method works for multiplying? You make a box here, and you put boxes below like this number. So you're taking 98 times 7, right? So you put 2 boxes below the 9 and 8. So like box below 9, box below 8, and then you make a row where the 7 is. So would you agree that 7 is a single digit? So it's one row going this way. These are columns. There's 2 columns, and there's 1 row. And what you do is before you start, you draw diagonal lines in these boxes. Every box would have a diagonal line going right through it. And how this works is how multiplication works. Is you just take this 8 times the 7. So it's 8 times 7. 56. And you put the number in there. It's a 2-digit number. Okay? What's 9 times 7? 63. You put that. And what you do is, for your final result, is you add the diagonals up. 6, 8, 6. And that's your result. That's like, it's very visual for multiplying. I'm not in that camp. I'm the person that does this. I do the column method for multiplying. This way I learned in high school, where you take 7 times 8, which is 56. You carry the 5 over, and then you take 7 times 9, which is 63, and you add the 5 to it. If there's numbers carried over, you add this to whatever the result is. So 7 times 9 is 63, plus that is 68. And that's my answer. Like, that's the way I learned it. I've definitely seen people multiply numbers differently. You know, like the very visual person. I can show you how to multiply using pickup sticks. Everyone ever play pickup sticks with like their grandparents? Okay, it's this game where you have this weird tube, it looks like a cylinder, right? It's just really tall. It looks like kind of like a pop can, and it's really tall. It's like a Pringles can, right? It's a Pringles can, right? And there's like sticks in there, like really thin sticks. They look like chopsticks, and they're all different colors. And there's one stick in there that's black. So what you do is you take this tube with all these sticks in there. There's like 30 sticks, and you turn it over, and all the sticks spill out onto the floor. And they're all like overlapping, and they're all cross-hatched over top of each other. And what you're supposed to do is you're supposed to find a black stick first. And what you're supposed to do is like you take turns with your partners, and you try to flip the sticks off of each other one at a time. So what you have to be like really visual, so that all the sticks are crossing, and you have to figure out, okay, what stick is on the top, and you put your little like black stick that you find right away, and you put it like underneath it, and you try to like flip it off the stack without disturbing any of the stack. If the stack moves at all, you have to put it right back, and your partner goes. So it's a really visual game now. It's stupid. It's what they used to play back way. Okay? But I can show you how to multiply using a little cross-hatching of sticks. So the number 98 is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the first number. And then 1, 2, 3, 4, 5, 6, 7, 8. And so that's the number 98. And then you put little cross hatches in there. I'm going to put the number 7 going this way. 1, 2, 3, 4, 5, 6, 7. Right? And what you do is you count up the actual numbers here and here, and that'll be your digit. You count how many times they actually crossed each other, and it will actually be 686 times. So it takes a long time, but it is literally like the most visual way you can teach multiplication. Okay, it's just this really like quirky little number. And how it works, you count up this number. This number will be a 2-digit number. I can already tell you that. And so whatever this number is, I know it ends in a 6, and whatever the front number of that number is, that number carries over, and whatever this cross-hatching is, which this number is something like, let's say it's like 60-something. Okay, it's 60-something. And what you do is you add this number to that number. And what you get is that this is the back number, and whatever you carry over, it adds with this, and eventually it makes this. Because this number will be like 60, let's say 63, and you'll add like the 5 across and make 68. So your answer is actually 686 times. Like that's just how you multiply with bigger things. Very visual. It's for usually they show this for like somebody who's very autistic. That needs like a visual representation of multiplying it. All right, but this is the actual like reason why we do distribution. We used it originally for like insanely big numbers, but making it easier to understand so you can do it in your head. So it's just this little quirky way. That's usually how I can multiply pretty quick. I think about, okay, what are easier numbers to multiply in my head? So for instance, like if I'm taking 6 times 103, I'm actually taking 6 times the 100, and then adding the 3 after it. So taking 6 and then multiplying across. So I get 600 plus the 18. 6 times 3 is 18. So it's 618 total. So that's just like an easy way to do distribution. Now, here's my goal today, because we got like 4 or 5 minutes left. I want to show you the real steps for distribution for algebra class. Because you can see like where it comes from and what it actually is. But a lot of people don't understand there's a lot of steps for distribution. So I'm going to go back to this like original problem that I kind of had written on the board earlier. I think it was something like this. I don't know exactly what it was, but it was something like that. Right? There's actually quite a few steps you have to do when you actually distribute numbers. A lot of people don't realize this. So the first step, when you have a problem like this, let's say this is my expression. The first thing you do is you hand the 3 to each item, like this. And I put it in the front of each because this is where the 3 is found in the front. That's distribution, right there. It's the simple fact of handing out items. The next step is now I move the parenthesis bars. So I'm going to move the parenthesis bars around the 3 and the 4. And I'm going to move the parenthesis bars around the 3 and the 2. Now, what property is it where you move parentheses? Associative. Yep. Okay. As I said, it's 100% guaranteed. You do distribution, the next step will be associative. That was your second property in the field one. Our third property in the field properties. Okay, now we just substitute. What's 3 times 4? 12. Okay. And what's 3 times 2? 6. And that's substitution. That's how you distribute correctly. There's always 3 steps. Like that's it. Just do it. Because when you actually do the math there, it's just substitute. You're substituting in the 12 for the 3 times 4, and you're substituting the 6 for 3 times 2, so it's all one step. It's all one easy property. Does that make sense what distribution is? Okay, tomorrow I'm going to show you a problem where it could be slightly different, where you could have a slightly different process, where maybe there's one more step, or 2 more steps, but it's still distribution. And then tomorrow is to kind of show you the basic property. So tomorrow is to be kind of like a little mini review. I don't know if I'll do an equation again, but we will definitely talk about these like expressions and talk about commutative and associative. So we haven't really talked about commutative a lot yet, but we'll eventually get there. All right, so there you go. Did everyone get a property sheet for me, or got one in their hand? Okay, good. Good deal. And if you were gone yesterday, make sure you get your page 139 turned in, if your name's on it, all good stuff. So we do technically yesterday. Fred and Michaela, make sure you set up a time where you can come and spend 10 minutes.